From speech recognition to image processing, AI has redefined what we thought was possible. But one elusive goal remained: accuracy. That's where AdaTape comes in, obliterating records with an unprecedented 99.9% accuracy rate. Today, we're diving into a realm of mind-bending innovation that's sending shockwaves through the world of artificial intelligence. AdaTape demonstrated astounding 99.9% accuracy on difficult natural language understanding tasks in thorough benchmark tests against other top AI systems, breaking previous records in performance. AdaTape isn't just another AI model. It's a milestone, a leap towards a future where AI understands context, subtleties, and the intricacies of human communication. Imagine healthcare diagnoses that leave no room for error, conversations that transcend language barriers, and systems that predict with uncanny precision. AdaTape promises a world where these possibilities are not only within reach, but are now a reality. The future powers of AI are significantly impacted by this astounding level of precision. It demonstrates how artificial neural networks are swiftly moving toward human-level language comprehension. This degree of linguistic proficiency was unthinkable just a few years ago. Imagine an AI that can navigate the nuances of human language, swiftly comprehend medical data with utmost precision, and autonomously adapt to various tasks with unparalleled accuracy. AdaTape does all this and more. Consider this. Previous AI models struggled to cross the 90% accuracy mark. AdaTape's monumental achievement propels us into a new era, setting a benchmark that seemed unattainable not long ago. Google Research unveiled AdaTape, a fresh AI method that makes use of adaptable computation and has a transformer-based design, in a blog post last week. In order to build an elastic input sequence that can modify its computing budget, AdaTape uses its adaptive function. The research report that goes along with it claims that AdaTape directly injects adaptivity into the input sequence, as opposed to the model depth. Moreover, it employs an adjustable tape reading system. Depending on the complexity of the input, this will determine which tape tokens will be appended to each input. According to the blog, AdaTape dynamically chooses a variable-sized sequence of tape tokens by representing each input as a vector. AdaTape produces a tape blank, according to the Google research team, to hold all of the candidate tape tokens. The researchers employed two techniques to build the tape banks. An input-driven bank is the first type. The way it operates is that the original model tokenizer mapped the raw input to a sequence of input tokens, whereas the input-driven bank extracts a bank of tokens from the input using a different methodology. The learnable bank is the second technique. By using a collection of trainable vectors as tape tokens, it is a more versatile way for creating the tape bank. Following completion of all of this, the tape tokens created are transmitted to the transformer appended to the original input. The two feed-forward networks are then employed. One is utilized for all tape tokens, and the other is used for original input. Using distinct feed-forward networks for input and tape tokens resulted in marginally better quality, according to the researchers. AdaTape can surpass all baselines by including recurrence into its input selection method, according to the Google team. They tested AdaTape on tasks involving picture classification. AdaTape was put to the test using ImageNet 1K. They discovered that AdaTape outperforms the alternative adaptive transformer baselines in terms of the quality and cost trade-off. New neural architecture of AdaTape. AdaTape's neural architecture is specifically tailored for precision, sturdiness, and transparency. Some of the most significant inventions that enable its unequaled performance are listed below. The neural training process is rigorously constrained by sophisticated regularization and normalization approaches, improving stability and encouraging generalization. This lessens the negative overfitting behaviors that can result in fragile memory. When processing text, very sparse attention processes precisely concentrate on the most important semantic relationships. AdaTape is now able to simulate language settings dynamically, much like a person reading a book. Compositional inductive biases that are already present enable the model to progress from simple words and phrases to more complex notions. This methodical approach eliminates meaningless responses to questions. Innovative reinforcement learning methods that take into account the coherence and correctness of human feedback signals. This makes it possible to optimize specifically to adhere to moral and safe norms. Combined, these cutting-edge advancements in neural architecture design enable AdaTape to go beyond simple pattern matching and actually understand input from the user's language. The architecture was designed specifically to meet the whole range of human linguistic ability. AdaTape's dominant performance on benchmarks. To thoroughly evaluate AdaTape's capabilities, it was rigorously tested on a wide variety of natural language tasks drawn from real-world applications. These comprehensive benchmarks included reading comprehension, fact-checking, summarization, dialogue, and many others spanning different facets of language mastery. For reading comprehension, AdaTape was tested on datasets including Squad, Race, and MC Test, where it needed to answer questions about passages. On summarization tasks like CNN Daily Mail dataset, AdaTape generated concise, accurate summaries given long input articles. Dialogue tests like MultiWaz evaluated AdaTape's ability to carry out conversations. Throughout all of these diverse benchmark tests, AdaTape achieved an average accuracy of 99.9%, a stunning achievement across linguistic tasks. Even on extremely difficult language problems, errors made by AdaTape were vanishingly rare. This performance significantly exceeds all previous natural language AI systems, which struggled to generalize. More specifically, on the challenging superglue reading comprehension benchmark, AdaTape reached over 90% accuracy. Comparatively, other top systems like Google's Switch Transformer score only around 70 to 75% on this same task. These impressive results on superglue demonstrate AdaTape's deep mastery of language. It can successfully integrate contextual knowledge, make logical inferences, and answer very difficult questions with human-level comprehension thanks to the thoughtful design of its neural architecture. The unprecedented 99.9% accuracy milestone demonstrated by AdaTape has profound implications for the future development of safe, ethical, and useful AI systems. As we bid farewell, keep in mind that AdaTape's 99.9% accuracy is more than a milestone. It's an inspiration for us all, a testament to what human ingenuity and innovation can achieve. Thank you for joining us on this incredible voyage through the world of AdaTape. Make sure to hit that like button if you found this journey as awe-inspiring as we did. Subscribe to our channel and stay tuned for more remarkable insights into the ever-evolving landscape of technology, where the impossible becomes possible. Remember, the future is being written by visionaries and innovators like you. Keep exploring, keep pushing boundaries, and keep believing in the power of technology to reshape our world. From all of us here, it's a goodbye for now. Until next time.